Hello students, welcome to my YouTube channel Datasha. In this lecture, we'll be talking about Milne's method. We have already discussed the algorithm regarding this, and in this class, we'll be discussing one more question that is related to Milne's method. In this question, we don't have the values of y at the various values of x, so we need to calculate that. So it's a different kind of a question. So let's consider the question. We have to use Picard's method to find out the values of y. So let me just write the question. As we know, Milne's method is a predictor-corrector method, and we need 4 values to find the predicted and the corrected value, right? So where so let me just write the question. So the initial values are given to us as x naught is 0 and y naught is 0. So we'll be doing this question. And to start off, let us see what is given to us. So given the equation, we have this. So as we know, we need to write the equation in the form of y dash is a function of x and y. So I'll be writing this in the form of f of x and y. So let me take the equation down because I'll be using this in the table. Now also I am given x naught is given to be 0, y naught is given to be 0, and the values of h, how we can find out the value of h? By seeing the value of x. So x naught is 0, and x1 is given to us as 0.2, x2 is given to us as 0.4, and x3 is 0.6. So what's the step difference between all these 4 values? That would be your h. So here our h is 0.2. Now what we need to find out, first of all, we need to find y1, y2 and y3. And after that, that's the first part. And in the second part, we need to find out the value of y at the other values. So in this, we will be finding the value of y at 1 or 0.8, and that is x4 is 0.8, and we need to find by 4. So this is what we need to find. So it depends upon the question. If you need to find out the 2 values, then you would be having y at 0.8 and y at 1. So you could calculate that as well. Now moving ahead, in the first part, we'll be applying the Picard's method. So the first part would be, we'll be using the Picard's method. So I hope you remember what is Picard's method. Let me just write the formula. So this is our formula for the Picard's method. So let us just, I'm so sorry. So this is our Picard's method. Now moving ahead, I'll be finding out, I'll just put n is equal to 0. So put n is equal to 0. So you will get y1. So that would be y naught plus x naught that is given to us as 0 to x, f of x, y naught dx. Now what is f of x, y naught? We can find out. Here I'll just here f of xy is x minus pi square. Okay, So in this, every time we'll need to substitute this value. So I'll just put here y naught is 0, 0 to x. That would be x would be just x only. Put the value instead of y, we'll be putting y naught. So I'll get here 0 square dx. So that is nothing but 0 to x, x dx. So finally, I'm getting here x square upon 2. So when I put n is equal to 1, I'll get y2, that is y naught plus 0 to x, f of x, y1 dx. So y1 would be this that you have calculated, x square by 2, we need to substitute. So let me just write this, 0 to x. So this would be x minus y square. Instead of y1 square, I'll be putting x square by 2. Okay, let me just, so that you don't get confused. So let me just write 1 y1 square. Okay, so this is nothing but 0 to x minus x square upon 2 whole square dx. So now we can separate this, and I'll be getting here 0 to x minus x4 upon 4 dx. So the final answer that I'll be getting here, that would be x squared upon 2 minus x5 upon 20. Now when I put n is equal to 2, I'll get the value of y3, and on the similar basis, I'll substitute here f of x comma y2 dx, and so x minus y2 whole square. So what is y2? This whole term is y2, so I just put it. So a minus b whole square formula you need to put it. And after this, what you will get, I'll just write the answer because I don't have the space here. So that would be x5 raised to the power 20, x11 raised to the x raised to the power 11 upon 4400, and x raised to the power 8 upon 160. So this is what I'm getting as my y3. Now, I hope this point would be clear enough. We just need to follow the Picard's method rule and find out the values of y1, y2, y3. Now we'll be formulating a table here. So I'll quickly formulate a table. And in this table, we'll be making 3 columns. The x, the y's, and the f of x, y's, we need to write down. So this would be x naught and y naught. This would be x1, y1. So we could just okay. So let me just write the x, the y, and the f of xy. That is x minus y square. Okay. So now we'll be applying the predictor corrector method, that means the Milne's method. So my x naught is 0, x1 is 0.2, x2 is 0.4, and x3 is 0.6. Now what is my y naught given to us as 0? y1, you can get the value of y1 when you will put here in this y1 x square by 2 So this would be 0.2 whole square upon 2. So you will get the answer as 0.02. So you just need to put in the values there, right? And y2 is, we will substitute the value x2 in this same, that is x square. So x2 whole square minus x2 raised to the power 5 upon 20. So in this, when I put the values after solving, I'll be getting this as my answer. Similarly, y3 would be x3 square upon 2 minus x3 5 upon 20, then minus x raised to the power 11 upon 4400 plus x raised to the power 8 upon 160. So the final answer that I'll be getting here would be 0.1762. Now, need to find out the f. So f of x naught y naught would be 0 minus 0 square. So my f naught is 0. Okay, so I'll be using these values. Now f of x1 y1 would be 0.2 minus 0.02 whole square. So after solving this, my f1 is coming out to be 0.1996. So this is my f1. F of x2 y2 would be 0.4 minus 0.0795 whole square. So f of 2 is coming out to be 0.3937. F of x3 y3 0.6 minus 0.1762 whole square. So f of 3 is equal to, so these are the values that I am getting. Now I'll be using the predictor method first of the Milne's method to find the value of y at 0.8, right? So let me just write the value here. So y at 4, this would be y naught plus 4 times h upon 3. The values twice of f1 minus f2 plus twice of f of 3. So y4 is nothing but y at 0.8 we are finding out. That is the predicted value. So y naught is 0. We know h is 0.2. So I'll write here. Just take the values of f1, f2, f3 from the table and calculate. So I have already done the calculations beforehand. So I'll just write the final answer here. So I'll be getting here, this would be equal to 0.8 divided by 3. After solving all of this, I'm getting 0.30488. So if this is a 5 decimal, we can approximate it to 4 decimal places. So it would be 3049. If you want to keep it as 5 decimal places, it's fine. Now I'll be calculating the F4 at the predicted value. So that means I'm calculating in f of x4, y4 predicted value. So the values of the value of f at x4 and y4. So that would be x4 minus y4 predicted value whole square. So that's 0.8 minus. So finally, I'm getting this as this. So I hope there would be no problem in this up till this point. So this is our predictor method. Now we move ahead and find out use the corrector method to find the corrected value. Now using the corrector formula, we get y 4c. This implies the corrected formula. So this is nothing but y2 plus h upon 3. Now I'll be using f2, f3 and f4 at the predicted value of f4. So that's equal to y 0.8 corrected value. So I'll get here y2 is 0.0795, f2 plus 4 times f3. So f3 I'm getting here as 0.5689 plus the f4 is 0.7070. So the final answer that I'm getting here is 0.3046. So this is my answer. Now in this we'll check our condition. So by 4 corrected value minus the predicted value, the modulus is coming out to be 0.3049 minus 0.3046. That's 0.0003. So now if I have taken it to be 0.001, so which is less than my epsilon, that is 0.001, say. So if the epsilon value, the error value is not given to you, you can assume it, and if it is given, you have to take that only. Now, in the question, it was not given, so I have taken this as my epsilon. And in this case, as my condition is holding true, so as this modulus is less than epsilon, so we stop here. And the value of y4 is coming out to be 0.3046. So if you wish to calculate the next value, that is y at 1, you can use the above values and you can find that too. So this is very easy method. So just you need to remember the Picard's method or any of the single step method that you could apply to find out the values of y. So y1, y2, y3 can be calculated using any of the Picard's method. So thank you so much, everyone.